Now we are going to see how these attention inputs are calculated at each step. Okay. We're considering the same setup. These are our decoders. These are our encoders. So this was the first time step, second, third, fourth, H1, H2, H3, H4. So these are the outputs of our LSTM blocks in the encoders at every time step. So what attention would do is it would take a weighted sum of all these vectors. So there would be multiple time steps in our decoder block also. In our decoder blocks also, there would be multiple time steps. Okay. So in time step 1, along with start of sentence, we pass C1, attention input, at time step 1, along with CT and HT, which we got after all the time steps in the encoder block got done. Now the output is produced, which is passed here. We get, let H4 be written as S0. Okay. So hidden states of our decoder blocks, let they be represented by S, and hidden states of our encoder blocks are represented by H. So S1, S2. So at time step 2, this would go in here along with C2, and it would produce S2. Now S2 along with, at time step 3, along with Y2 will go into it, and it will produce S3. Okay. Here C3 will also be going into it. Okay. When we talk about the outputs Y1, Y2, Y3, we are talking about the hidden states, because hidden states are, we do certain operations on our hidden states, like we apply softmax or we pass it through feed forward neural networks. So whatever it is, we obtain our output vector only after we do certain operations on our hidden state at every time step. So we can see at every time step in a decoder block, we are passing C1, C2, C3. These are the attention inputs. So C1 would look something like, this is how C1 would look. C2 would look like. So this is how all the attention inputs would look. So all the attention inputs would be different because the weights would be different in all the cases. These are the alignment scores or similarity scores. Okay. If we take alpha to 1, okay, let's do some discussion on this. So alpha 21 basically gives information of how much role would the first element of the encoder block, first element, first output, would play in the output generation in time step 2. Okay, how much this y2 vector which is produced by the decoder block in time step 2 would depend on this h1. It is decided by this alignment or similarity score. So if you see this entire setup, you would see that alpha 21 is dependent on first hidden state. Okay, alpha 21 was written here for C2, right? So it was written for C2. So it would be dependent on S1 also. Okay. So if you generalize this, this would look something like it would look like some function. Okay. Let's start writing this for alpha 23. It would look like this. So we are writing for time step 2, right? So it's dependent on the third hidden state of the encoder block along with the hidden state of the first decoder block. First decoder block means the first time step. Okay. So this is how all the alignment scores can be calculated. It's by taking a function of these vectors.